Right now, while you are reading these words, something is happening that almost nobody on Earth knows about. A machine the size of a small car, built before the internet existed, before home computers existed, before most of the scientists studying its data were even born, just did something it was never supposed to do. It turned around, not physically, not the way a spacecraft maneuvers in a film, but its sensors, its instruments, the eyes and ears we attached to it before launching it into the void in 1977. They just registered something coming from a direction nobody was watching. A direction that, according to every model ever built to describe what exists out there, should have had nothing in it worth detecting. The data arrived 4 minutes ago, after traveling at the speed of light for over 22 hours across a distance so vast that most numbers used to describe it lose their meaning. And the engineers at NASA's Jet Propulsion Laboratory who received it are not using words like interesting or unexpected. They are going quiet in the way scientists go quiet when something does not fit, when the data lands on the screen and the frameworks they have spent careers building do not produce an explanation. By the time this is over, you will not think about deep space the same way again. Before you can understand what Voyager 1 just found, you need to understand something that most coverage of this mission completely misses. Voyager 1 is not just far away. It is in a fundamentally different part of the universe than anything else humanity has ever placed an instrument. In 2012, 35 years after it launched, Voyager 1 crossed the heliopause. If you have never encountered that word, it describes the single most important boundary in our cosmic neighborhood. The sun does not just produce light and heat. It continuously releases a stream of charged particles called the solar wind, and this wind blows outward in every direction, pushing against surrounding space and forming a giant protective bubble around our entire solar system. Everything inside that bubble, every planet, every moon, every asteroid, every comet, every spacecraft ever launched, every living thing that has ever existed, is inside the heliosphere, the outer edge of that bubble, where the solar wind finally runs out of energy and gets pushed back by the pressure of interstellar space pressing in from the other side, is the heliopause. It is the actual physical boundary of our solar system. Everything inside it is ours. Everything outside it is something else entirely. Voyager 1 crossed through that boundary and came out the other side. It became the first object in human history to leave the solar system. Not a metaphor, not a technicality. The first physical thing our civilization has ever sent into the actual space between stars, and it is still transmitting. Right now, we have a live instrument sitting in interstellar space, not orbiting a planet, not floating in the outer solar system, actually inside the dark, cold, ancient space that lies between star systems, a space that no scientist, no telescope, no model built from the ground has ever been able to directly observe from the inside. For decades before Voyager 1 got there, scientists had built detailed mathematical models describing what interstellar space should look like, not guesses. Serious, peer-reviewed, rigorously tested models built by some of the most capable physicists alive. And those models all told roughly the same story. Interstellar space should be relatively quiet, relatively smooth, a thin, cold, sparse environment where particles drift slowly and not much happens, a kind of cosmic waiting room between star systems. Voyager 1 entered that waiting room and found it was actually a storm. The plasma between stars is not quiet. It has structure at scales from meters to millions of miles. It is turbulent in ways that existing physics did not predict. The magnetic field at the boundary between our solar system and interstellar space does not transition smoothly. It crackles with energy, with particles slamming into each other at speeds approaching a fraction of the speed of light, generating temperatures near 30,000 degrees Celsius in what was supposed to be cold, sparse transitional space. Some researchers, looking at what Voyager 1 found at the heliopause, described it as a wall of fire. And that description, dramatic as it sounds, is physically accurate. Then came the 2023 crisis, and this is the part of the story that makes what happened 4 minutes ago even more extraordinary. In late 2023, Voyager 1 nearly died. For 5 months, the spacecraft continued transmitting a signal back to Earth, but what it was transmitting was gibberish, corrupted code, scrambled data that the engineers at JPL, after decades of experience reading everything the spacecraft had ever sent, could not decode. The instrument was still alive, the signal was still coming, but whatever it was trying to say had become unreadable. The cause, when they finally identified it, was both simple and devastating. A single memory chip inside the spacecraft's flight data system had physically deteriorated after nearly 5 decades of constant exposure to cosmic radiation. One small piece of 1970s hardware, measuring a fraction of an inch, had developed a fault that was corrupting the section of software responsible for formatting and transmitting scientific data. No alarm had gone off. No warning had been sent. The chip had just quietly failed after 46 years of non-stop operation in the harshest environment a human-made object has ever been placed in. In any normal engineering situation, you fix a broken component by going to where it is and replacing it. In this situation, the component was 15 billion miles away, unreachable by any known form of transportation, with no repair mission possible in any time frame that would matter. The only tools available were radio signals traveling at the speed of light, and even those signals took 22 hours one way to reach the spacecraft. 22 hours just for a message to arrive, another 22 hours for any response to come back. Think about what that engineering process looked like from inside the control room. You look at a piece of data, you form a theory about what might be wrong. You write a set of instructions designed to test that theory. You transmit those instructions, you wait 22 hours, you receive whatever the spacecraft sends back. You analyze the response, you discover something slightly different from what you expected. You form a new theory, you write new instructions, you transmit them, you wait 22 hours again. You continue this process step by patient step for months. And every single moment of that process carries the knowledge that a single wrong instruction sent across 15 billion miles of void could permanently end the mission with no recovery possible. The team at JPL worked through this for months, carefully, methodically, under a kind of pressure that most engineering situations never produce. They figured out that the corrupted code could not be repaired, but it could be relocated. The affected software was split into smaller sections and stored in different parts of the spacecraft's available memory, carefully reconnected to function as a whole. It was, in effect, brain surgery performed remotely through a 44-hour time delay on a machine nearly 50 years old sitting 15 billion miles away. In mid-2024, Voyager 1 came back online and began transmitting clean, readable, complete scientific data again. The spacecraft that should have died in 1981 had come back from what could have been its final silence, and what it immediately resumed sending back was more evidence of something that had been building in the data for years, something that none of the models built to describe interstellar space had predicted, something that, 4 minutes ago, produced a reading so unusual that the team receiving it stopped and read it twice. Let me be precise about what Voyager 1 detected. The spacecraft carries an instrument called the Cosmic Ray Subsystem. Its job is to count high-energy particles arriving from various directions, particles that originated from exploded stars, from distant galactic events, from sources spread across the galaxy. These particles stream through interstellar space constantly, and measuring their direction, energy, and intensity tells scientists something about the structure of the medium they are traveling through. For years since Voyager 1 entered interstellar space, those cosmic ray readings followed an expected pattern. More particles from certain directions, fewer from others, varying in ways that corresponded to the known magnetic structure of the local interstellar medium. Predictable, mappable, a reliable background against which other measurements could be calibrated. 4 minutes ago, that pattern changed. Not subtly. Not in the way a reading drifts when an aging instrument develops a gradual fault, sharply, in a way that registers as an event rather than as noise. The cosmic ray flux from one specific direction dropped, not to zero, Not completely, but enough to be statistically unmistakable. Enough that the instrument flagged it automatically before any human analyst had looked at the data. And simultaneously, from the opposite direction, the flux increased by a corresponding amount. Something changed, the distribution of cosmic rays reaching Voyager 1. Something between the spacecraft and whatever lies further in the direction the original flux came from. Something that was not there before. The first instinct when any unusual reading arrives from Voyager 1 is hardware failure. After 47 years of operation in interstellar space, the spacecraft's components have degraded beyond any designed lifespan. Memory chips have developed faults. Circuits have been bombarded by cosmic radiation billions of times. The 2023 crisis showed exactly how that degradation can produce unexpected outputs. The reason hardware failure does not explain today's reading is the same reason it did not explain the anomalies from 2017 onward. Instrument failures produce noise, random errors, gradual drifts, outputs that do not have consistent physical meaning. What the cosmic ray subsystem detected is not noise, it is a pattern. A directionally coherent, physically consistent pattern that describes something real happening in the medium surrounding the spacecraft. A failing detector does not produce a simultaneous decrease in one direction and increase in the opposite direction. That kind of paired response requires an actual physical cause, an actual change in the environment the instrument is measuring. The engineers at JPL know this. They have known it for long enough that the initial rush of careful skepticism, the systematic checking of instrument health logs, power readings, calibration data, is already underway. And the instrument health logs are returning normal, the power readings are stable. The calibration data matches expected values. The instrument is working correctly. What it detected is real. Now the question becomes what produced it. There are several physical scenarios that could cause a directional shift in cosmic ray flux at Voyager 1's location. Each one implies something different about what exists in that region of interstellar space. The first possibility is a density enhancement in the interstellar medium, a region of higher than average plasma density passing through Voyager 1's location. Dense plasma can deflect cosmic rays, changing the flux arriving from particular directions. This would be consistent with the structured, turbulent interstellar medium that Voyager 1 has been documenting since 2017. The medium is not uniform. It has filaments and clumps and variations that the spacecraft has been mapping as it moves through them. A particularly dense structure, encountered at the spacecraft's current position, could produce exactly the signature observed. The second possibility is a magnetic structure, a region where the galactic magnetic field is configured in a way that channels or deflects high-energy particles. Magnetic fields in the interstellar medium can act like lenses or mirrors for cosmic rays, focusing them in some directions and depleting them in others. The discovery that the solar system and the interstellar medium are magnetically connected at the heliopause, a finding that contradicted decades of models, suggests that the magnetic architecture of interstellar space is more complex than anyone predicted. A magnetic feature of sufficient scale and configuration could produce the cosmic ray signature Voyager 1 just detected. The third possibility is something that has no prior detection history at all. Voyager 1 is the first instrument ever placed in interstellar space. The environment it is moving through has never been directly measured before. The models describing it were built from observations made at a distance, filtered through the very heliopause that the spacecraft had to cross to get here. It is entirely possible, not certain, not even likely, but physically possible, that the interstellar medium contains structures or phenomena that existing models have no category for, because no instrument had ever been close enough to detect them. The data does not yet distinguish between these possibilities. That process takes time. The careful comparison of today's readings against the full history of Voyager 1 data, the modeling of candidate scenarios, the analysis of whether the detected pattern matches the predictions of known physical processes. What the data does establish, clearly and without ambiguity, is that something changed. something between where the cosmic rays were coming from and where Voyager 1 is sitting modified their distribution, and that something was not there before. Here is the detail that changes the weight of everything else. On November 18th, 2026, a date already locked into the calendar, already certain, Voyager 1 will reach a distance of exactly 1 light day from Earth. That means it will be so far away that a signal moving at the speed of light, the fastest anything in the universe can travel, will take exactly 24 hours just to reach it. If you send a command to Voyager 1 on a Monday morning, you will not know if it arrived until Tuesday morning, and you will not receive the spacecraft's response until Wednesday morning. 2 full days of waiting just to complete a single exchange of information. No human-made object has ever been that far from Earth, not once in the entire history of civilization. And Voyager 1 will cross that threshold while it is still alive, still transmitting, still sending back data from the only direct vantage point into interstellar space that our civilization has ever achieved. And it will keep going. Every hour it travels approximately 61,000 kilometers deeper into the dark. The communication delay will keep growing. The power supply will keep shrinking. And somewhere in the early 2030s, the last instrument will reach the minimum power threshold, and the last signal will begin its journey home and arrive and be recorded, and there will be nothing after it. After that, Voyager 1 will just keep moving silently at 61,000 kilometers per hour, carrying its golden record through the darkness, passing through regions of interstellar space that human instruments will not reach for tens of thousands of years. The cosmic ray anomaly detected 4 minutes ago may be one of the final significant discoveries this spacecraft makes before that silence comes, or it may be the beginning of something that unfolds over weeks of careful analysis and produces an understanding of interstellar space that reshapes how we think about everything beyond the heliopause. There is a fact sitting in the middle of this story that is easy to miss when you are focused on the physics and the engineering. Right now, the only live scientific instrument that humanity has ever placed in interstellar space is 47 years old. It was built using technology that predates personal computers. It runs on power equivalent to a few LED light bulbs. The refrigerator in your kitchen uses more electricity than Voyager 1, and it is sending back information that is changing how we understand the universe. We have built things that are much larger. We have built things that are much more powerful. We have built things that cost far more and involve far more complex technology. And none of those things have told us what Voyager 1 is telling us right now. Because none of those things had the one quality that Voyager 1 had. None of them had the endurance to keep going long enough to actually get there. There are questions about the universe that can only be answered from inside the universe, not from a telescope on the ground, not from a satellite in Earth orbit, not from a mission to Mars or the asteroid belt, only from a machine that crossed the heliopause and entered the space between stars. We have exactly one such machine. It is old and running on the power of a nightlight, and as long as it is still transmitting, every signal it sends back is irreplaceable. The investigation into today's reading has already begun. The data is being compared against the full archive of Voyager 1 measurements going back to 2012, when it first entered interstellar space. Analysts are running models of candidate physical scenarios. The instrument health logs are being reviewed for any sign of the degradation that has, in the past, produced false positives. The answer may come quickly if the pattern matches a known phenomenon. It may take weeks if the analysis requires comparing multiple data sets and running complex simulations. And it may remain partially unresolved if the power budget does not allow for the additional measurements that would be needed to distinguish between competing explanations. But the data itself is not in question. The cosmic ray flux changed. It changed in a directionally coherent way. It changed in a way that describes something physical happening in the interstellar medium at Voyager 1's location. Something is there that was not there in any previous measurement. Something that the spacecraft, in the process of moving through interstellar space at 61,000 kilometers per hour, has just passed close enough to detect. It may be a density enhancement in the plasma. It may be a magnetic structure. It may be something that existing models do not yet have a name for. The signal is still coming, stretched across 24 billion kilometers, delayed by 22 hours of travel time at the speed of light, carrying information about a universe that continues to be stranger, more structured, more surprising than any model built from Earth ever correctly described. One machine, 4 watts, one chance to listen. The question is not whether the discovery matters. The question is what it means. And right now, in a control room in Pasadena, the people best equipped to answer that question are working through the data, carefully and methodically, the way they have been doing for 47 years. When they find the answer, it will arrive the same way every answer from Voyager 1 arrives, traveling at the speed of light across a distance that takes nearly a day to cross, a thin whisper from the edge of everything we have ever reached, from a machine that was supposed to last 5 years and has been speaking to us for nearly 50. Whatever Voyager 1 just turned toward, it found something, and we are still learning what. Let me tell you what makes this moment different from every previous Voyager 1 anomaly. When the 2023 communication crisis happened, engineers knew what they were dealing with within a few weeks. Hardware failure produces recognizable signatures. The corrupted data from the faulty memory chip had characteristics that, once identified, pointed clearly toward a specific cause in a specific component. What today's cosmic ray reading produces is something different. It does not have the signature of hardware failure. It does not match the profile of any instrument degradation that the Voyager team has documented across nearly 5 decades of operation. The reading is clean, consistent, physically coherent in a way that hardware noise never is, and it is coming from a direction that Voyager 1's instruments have been pointed at continuously since the spacecraft entered interstellar space in 2012. 12 years of readings from that direction, establishing a baseline so thoroughly documented that any deviation from it stands out immediately. This is not a baseline deviation that looks like noise. It looks like a signal, a physical event occurring in the interstellar medium, detectable because Voyager 1 happened to be in the right position at the right moment. The right position, in this case, is a position that no other instrument in human history has ever occupied. Interstellar space, the space between stars, the region that every model of the universe beyond our solar system has been built to describe from the outside, because until 2012, nothing we built had ever been inside it. There is a generation of astrophysicists who have spent entire careers studying the interstellar medium without ever having direct data from inside it. They built their models using observations from Earth, from satellites, from radio telescopes that measure the properties of interstellar plasma indirectly through the way it affects signals from distant pulsars and quasars. It is like trying to understand the interior of an ocean by standing on the shore and measuring how waves arrive. Voyager 1 put an instrument in the ocean, and the ocean turned out to be nothing like what the models built from the shoreline had described. It is turbulent where the models said it would be calm. It is structured at scales the models did not account for. The boundary between our solar system and interstellar space is not a gradual transition, but a sharp, energetic, physically dramatic interface that operates nothing like the theoretical boundary diagrams that were taught in physics courses for decades. Every measurement Voyager 1 has sent back from interstellar space has required some revision of the models. Some revisions have been small, adjustments to density parameters, corrections to magnetic field orientation predictions. Others have been larger, the discovery that the interstellar medium has persistent oscillations that no model predicted, the finding that the heliosphere and the galactic magnetic field are connected in ways that were not accounted for in any theoretical framework. Today's reading falls into an as-yet undetermined category. The analysis is ongoing. The classification of this anomaly, whether it represents a small revision or a larger one, depends on data that has not yet been fully processed. But the fact that it does not match any previously recorded pattern in 12 years of continuous observation from the same instrument is itself significant. Voyager 1 has seen a lot of variations in the interstellar medium. Many of them turned out to have explanations that fit comfortably within existing frameworks. Some are still being analyzed years later. This one has the profile of the latter category. Not because it is dramatic, in raw numbers, the change in cosmic ray flux is measurable but not enormous, but because it is directionally coherent, physically clean, and does not resemble any pattern in the historical record. Here's the part of this story that deserves to sit with you after everything else. Voyager 1 was launched in 1977 carrying a golden record, a gold-plated copper disc containing sounds and images chosen to represent life on Earth. Music from cultures across human history, the sound of rain, the sound of ocean waves, human laughter, greetings spoken in 55 languages, mathematical diagrams designed to show whoever might find the disc where it came from and who made it. Carl Sagan, who helped design the record, described it as a message in a bottle cast into the cosmic ocean. The record is still attached to the spacecraft. It has been traveling through interstellar space since 2012. As far as we know, nothing has found it. Nothing has responded to it. Nothing in all of interstellar space has given any indication that the message exists. But 4 minutes ago, something in that space produced a reading that the spacecraft's instruments detected and encoded and transmitted home. Something changed the distribution of cosmic rays reaching Voyager 1 from one specific direction. Something that was not there before is there now, or something that was there before is no longer there, and the difference was large enough for a 47-year-old instrument running on 4 watts of power to notice. We sent a message into the dark. The dark has not responded in any way we can interpret as a message. But the dark is not empty, and the dark is not static, and every day that Voyager 1 continues to function and transmit, we learn something about what is actually out there, something that we could not have learned any other way. Whatever is out there today is something we did not know about yesterday. Whatever produced today's cosmic ray anomaly was there all along, waiting in the interstellar medium, unmeasurable from Earth, invisible to any telescope, impossible to detect by any means other than putting an instrument physically in the space where it exists. That is what exploration actually looks like. Not the clean, triumphant version, the real version where an ancient machine sends back a reading that does not match the models, and the people responsible for understanding it sit down with the data and begin the slow, careful work of figuring out what it means. The signal is still coming. The investigation has just begun. And somewhere in interstellar space, Voyager 1 keeps moving. 61,000 kilometers per hour, farther every second, carrying its golden record through territory no instrument will map again for a very long time. Whatever it turned toward, it found something. The question that remains, the one that the data does not yet answer, the one that the analysis has just begun to approach, is what that something actually is.